Question 1. Enter the information in the map below and answer the following question. Now the questions that follow. The Suez Canal is an artificial sea level. The Suez Canal is an artificial sea level waterway running 193 kilometers between you take note of these numbers. Never know, you might know. It's between Port Said in the north and Suez in the south. Suez Canal offers a shortest route measure ships carrying cargo around the world. Construction of Suez began in September and was first opened in 1969. When they first opened, 8 meters deep, 200 meters wide at the bottom, and 61 to 91 meters wide at the surface to allow ships to pass each other. Passing bays were built 8 to 10 kilometers. We are highlighting numbers because we might need to deal with them. Here's a diagram, here's a map. Identify the country that borders the Suez Canal on the western side. So first and foremost, look for the Suez Canal. The Suez Canal is here. The Suez Canal is here. So this is the north, and we need the west. So they are saying identify the country that borders the Suez Canal on the western side. The western side, it's the country, not the continent. So it's Egypt. So you write down the names of the continents. The names of the continents separated by the Suez Canal. First and foremost, we have continent. We have what? Africa. Then when you come here, we have Asia. Africa and Asia. Identify the sea that is found on the southern side of the Suez Canal. So here we are. This is the north, the south, and the sea that we see, it's this one here. It's supposed to be the Red Sea. Write down the distance between the city at south of Suez Canal and the city at the north of the Suez Canal. Give your answer in kilometers. Say write down the distance between the city at the south, and so we shall see up here. We come back and we see the Suez Canal runs 193 kilometers between the Port Said north and the Suez south. So this is the distance that you're looking at. So they said you want it in meters. So it will be 193. Oh, they said in kilometers. It's fine. 193 kilometers. Mention one advantage that the ships have when using the Suez Canal. They said it's the shortest route. They can pass each other. The advantages, they can pass each other. It's a shorter route. Allow the ships pass each other. Artificial runway with the shortest. Okay, we go to 1.1.6, mention any two items that a ship using the Suez Canal could transport. This is obvious. We have, you can talk of, they might be transporting oil, they might transport, what is it called? Vehicles, which are cars. You know, ships transport a lot of things, etc. Give one reason why passing bay were built every along the length of the canal. The reason is here to allow ships pass each other. Passing bays were built. You come here and say allow ships pass each other. Determine the number of years it took for the Suez Canal to be opened. The maritime sea going traffic from the time construction began. Let's see. Here we go. It began in, so we are determining the number of years. It's from 1859, 1869. So we shall need to subtract, which will be 1869 minus 1859, 5956. So they were 10 years. That's the time they were looking at. One point two. On 23rd March 2020, the 1,300 feet ship, the ever given, traveled from Asia to Europe. It entered the Suez Canal in the south and sailed north. The ship got stuck in the mud right across the southern part of the canal. In which direction was the ever given sailing through the Suez Canal? So come here, you see it got stuck. So it was from, you see, it was traveling from, entered the Suez Canal in the south and sailing to the north. So south, it was heading up there. So they're asking you in which general direction? In which general direction was the ship? This one supposed to be? In which general was the evidence sailing through? It was sailing through the southwest. It's the northwest, not southwest. Because it's here and it's heading that direction. It's going like that. So this is northwest. At which city did the Everest enter the Suez Canal? At what city? It entered from south here. So we come here, we say the Suez Canal is at visual level running between Port Said in the north and Suez in the south. So it entered through the Suez. Because it began from the south going north. So the Everest convert the length of the container ship to meters if 1 feet equals to that. So this is so straightforward. If 1 feet equals to 0.3048 meters, what about if you have 1,300 feet? What will it be? We don't know. So what do we do? Cross multiply. This might not be important because this one you will use it to find out whether you're going to multiply or divide. But this is what is needed. You show us that you are multiplying. These are meters. 1.3, the chef on the ship prepared chocolate months for the crew members. Say the recipe below that he used and answer the questions that follow. These are the ingredients. And when you look at these ingredients, they will serve 6 people. It's prepared or cooked for 5 minutes. Preparation is 10 minutes. The method is here. This is what you follow. All right. Determine the total time in hours that it will take to prepare and cook the chocolate mousse. So we go here and you see 50 grams of dark chocolate broken down, resting in peace into small pieces and melt in a pot. Here in the one whisk the eggs. It's no time here. Pour the other 2/3 of the grate. The spoon mixture 6 bubble and remaining grated chill in the fridge for 2 hours. Yes. So here we've seen the 2 hours plus 5 minutes plus the 10 minutes. So in other words, it's 2 hours and 15 minutes. But the question says time in hours. So you divide the 15 minutes to change it to hours, which will become 2.25 hours. Sorry, determine the total time in hours that it will take to prepare and cook. Sorry. This was prepare and cook. Prepare and cook. We prepare for 10 minutes and we cook for 5 minutes, which is what? In 15 minutes change to hours, become 0.25. But these are hours. Convert the weight of the dark chocolate to kilograms. Shall come here and look for dark chocolate, 200 grams to kilograms. Grams to kilograms, what do we do? Grams to kilograms divided by 1,000. So this become 200 divided by 1,000. Answer will be 0.2 kilograms. Write down the ratio of the custard sugar to brandy in its simplest form. So we shall look at the quantity of custard sugar, 60 mils. Then the brandy is 30 mils. They said ratio, it's what? Custard sugar to brandy, which is 60 mils to 30 mils. So simplified form, it will become 2:1. For every two portions of sugar, we need one option of brandy. Determine the number of grams of grated chocolate that will be added onto the cream. We come back here, we'll see they said pour in the cream and add 2/3 of the grated dark chocolate. But they say grate 50 grams of dark chocolate. So we shall say 2/3 of 50. 2/3 of 50. Which is 33.33 grams. The chef started making the most at 11:55. At what time will it be ready for eating? Okay, it will be 11:55 plus the 15 minutes, the 10 and the 5, plus the 2 hours. So here we put 15, nothing there, then the 2 hours. This becomes 0, you carry 1, you put it here, this becomes 70, that means you deduct with 1, carry 1 here, 1 plus that, you get PRELIM 2022. All right, it says the Royal Mail ship St. Helena was a unique cargo passenger ship built in 1989, specifically to supply the island of St. Helena, a British overseas territory in the tropical South Atlantic Ocean. The Royal Mail ship St. Helena can accommodate 156 passengers and 56 crew members. Select the information and the map above and answer the following questions. Determine the probability that, that's question number 2.1.1. Determine the probability that if a person could be picked at random from the ship, it would be a crew member. Give the answer as a percentage. All right. When you look at probability, first and foremost, probability will always equal to sample over the population. All right, population simply meaning the number of items you're going to pick from. Sample the item you're going to pick. Now, when you look at this, it's a predetermined probability if a person picked at random from the shape could be a clue. So the sample is going to be the clue member. Then the population is going to be the total number of people who are there. So we shall look for the total number of people who are there, which will equal to 56, remember, plus 156. We are looking at this. We have 156 members and we have 56 crew members. So all in all, how many people do we have? We have 156 plus 56. We end up having 212. So we have 200 we have 212. So out of 212, what is the chance that you're going to pick a crew member? What is the chance that you're going to pick a crew member? When we add this, we have this much. This is our population now. So the probability will become probability of picking a crew member. How many crew members we have? 56 out of 212. But remember, they said as a percentage. So multiply by 100. Multiply by 100 and we end up having 26.42%, which is approximately 26%. 26%. Number one, how do we mark this? Did you get the concept? 1 mark. Did you multiply by 100? 1 mark. Did you get your answer? They said as a percentage. Still meaning it to a full number, whole number. Yeah, it's fine. Even though you have this 1 marks. That's how we got the 3 marks. All right, we look at question 2.1, 2.1.2. The passengers on the Royal Mail ship St. Helena are of the following nationality. We have South Africans, we have Russians, we have Americans, German. All right. We have people from South Africa, we have people from Russia, we have people from America, we have people from Germany. All right. Determine the probability. Again, we are looking at probability. Determine the probability that if a passenger is selected at random, the passenger will be a Russian male passenger or South African female passenger. So here we go. As I told you, remember probability, we're looking at the population and the sample. So the sample here we have Russian male, South African female. All right, what do we do here? What we do, we shall get the Russian male, I'll write it like RM plus the SA female over the total number of people that we are looking at, which we shall call the population, right? The total number of items that we are looking at. So we shall come here, Russian male, come here, Russia male, it's 8 plus female South African, female South African. So we are looking at those two values over the total, which is supposed to be 48 plus 12 plus 56 plus 23. You understand? So here we come. Now they said probability. They didn't say as a decimal, as a percentage, so it can't multiply by 100. So when you add 8 plus 13, this is a 21. 21 over, when you add all these numbers down here, you get 139. So this is the probability. That is the probability. All right. It's fine if someone displayed it as a percentage, you will get your full marks. Even the person who displayed it as what? as a decimal, you also get a full mark. It's fine. But even though you stop here, it's also fine. How do you get the mark? You selected the right values. You divided by the right values. You got the right answer. You understand? So 1, 2, 3, 4. That's how we get the 4 marks. All right, let's look at question number 2.2. 2.2. The Royal Mail ship St. Helena departs from Cape Town to St. Helena. Study the map of the St. Helena in annexure A and answer the questions that follow. Let's go to annexure A. Wonderful. This is the annexure. I'll leave it small for us to see it fully. All right, annexure A, question 2.2. We are looking into the addendum. All right, the question. All right, this is the map. You look at it, you see it's called St. Helena. These are the dots, these are towns. Some towns are inland, others are offland. They are inland, the opposite of inland, they are supposed to be coastal. They are found on the coast. Anyway, let's go there and we see. Where is the harbor on St. Helena likely situated? We go to the map and we see which town do we have here. St. Helena, where is it likely to be? Definitely it can't be inside. You understand? So it has to be outside here because this is water. And a ship can't be inside the land. A ship can't it can't be on the land. It's supposed to be inside the water. So which of the towns is likely to be? It can't be this because this one is inside. It can't be this. Also, this is inside. This Longwood is inside. St. Paul's is inside. Half Tree Hall it's inside. Apart from Jamestown Town. So the harbor is likely to be in Jamestown Town. All right. That's where it's likely to be situated. Why? Shape can't be inland. It's supposed to be on the coast. All right. Choose the correct letter that would make the following statement true. The town of Leewood lies south of Longwood, west of Blue Hill, southwest of Jamestown. Let's go there and we say, they said the town of Leewood lies south of Longwood. Longwood is, let's say, when we try to put a compass here. Okay, so a little bit south, okay, because it lies south of, okay. Then we say west of Blue Hill, we come to Blue Hill. No, man, this is north, east, west, south. So this option is out. It's not used. Southwest of Jamestown, here we are. 1, 2. We connect coming inside. No, this is southeast. Also, this is wrong. So this is what? Right. Let's go back to the question and we see. So the right one is supposed to be A, south of Longwood. These ones were all wrong. We saw them the other side. All right. We continue. Let's see question number 2.2.3. What type of scale is shown on annexure A? Let's go to annexure A. There any scale? Wow, there is one here. This is a scale. The name for this scale, it's called a line scale. A line scale. The line scale, then others would call it a bus scale, but a bus scale would be complete with with the bars. You understand what I'm trying to say? Okay, let's go there and you see. So this is supposed to be a line scale. You saw how it looked like. Use the scale on the map to determine the distance as the crow flies from Longwood to St. Paul town. Give the answer in kilometers. Now, this term here, as the crow flies, this simply means it's a straight. It's a straight what? A straight line. Remember, this is a kind of a bird that flies. So a bird doesn't follow any route. It has no GPS. So we can't follow the routes the way they go. So simply meaning you're supposed to come here. You take your ruler. Now, the towns that we're going to look at, we are looking at Longwood and St. Paul. Longwood and St. Paul. Longwood and St. Paul. This is St. Paul and this is Longwood. It's a straight line, eh? So don't worry about your answers. You put your ruler there. Put your ruler there. And you measure from here to this place here. You measure this distance here. Together. So having measured, people might have got, in most cases, actually, for you to get the right answer, measure in millimeters because those lines are there. If you measure in centimeters, you always be having a number that's missing. So here I've got my answer as 42 millimeters. Sorry, it's not 42. I got my answer as 37. Don't worry about when you measure, you can get 38. And I've got 37. Someone might measure and someone might have measured and they've got 36. It's fine. We are still on the same route. Why? We are using different rulers. All right. So having measured this, remember they want the distance to be in. They say use the scale on the map, determine the distance. Use the scale on the map. So we've measured this is the distance on the map. So we are going to use the scale also. So I'll come here. I'll come here and I measure this distance here. I measure from here to here. Yeah. When I measure from there to there, what do I get? First I measure the distance, then I've measured the scale. All right. When I measure this, I end up having 42 millimeters. Yours might be different a little bit. Might be 40, 41, 43. It's fine. You understand why we are using different rulers. Anyway, so here we have 40. So this will mean if I have 42 millimeters equivalent to 5 miles. You see that? But the distance I measured, they want me to find out, it's what? The distance between St. Paul and Longwood. So if 42 millimeters are equivalent to 5 miles, what about if I have 37 millimeters? What will they be? I'm asking myself. So what happens? I'll cross multiply the 5 multiply the 37, which will equal to 42 times the h. So I divide through by 42. I divide through by 42. So I've got 185 divided by 42. So my answer here is 4,40478. I'm leaving it like this because I'm going to convert it. But these are what? Miles. The question wants these miles to become kilometers. Are we there? The question wants the miles to become kilometers. Let's go there and we see it. We measure the distance between these two towns. We got the answer as 37 millimeters. We measured the scale and we got 42 millimeters, equivalent to 5 miles. If 42 is equivalent to 5 miles, what about the 37? Definitely it can't be more than that. Anyway, we said we shall take the 42 times the unknown later, giving me 5 times 37. I'm repeating this for those ones who have not seen how we've done it before. So for we divide through by 42, we divide through by 42. This has to go with that. So my unknown distance will equal to 4,408. These are miles. The question wants us to get the distance in kilometers. So we shall change the miles to kilometers using the conversion factor. The conversion factor states 1 mile is equivalent to 1,60934 kilometers. So if you have 4, that means it's going to be up. So what we do? We shall multiply by 1 comma. We shall multiply by 1 comma. We shall multiply by 1 comma 60934, which will give us 7,09. These are kilometers. All right. This answer might change according to your measurements. My measurements are these ones here. Please take a ruler. It's fine. You can pause the video, work it out. All right. Let's look at question number. Give one reason why certain towns on the map are indicated with larger dots than other towns. The reason might be these are main towns. Someone might say they are major towns. Another one might also say they are big towns. Or another person can say they are harbors. Yeah, a harbor is a place where ships dock. You understand? Planes, they land on the airport. Taxis, they go to tax ranks. Buses, they have a bus station. You understand? Ships, they dock. Also boats, they dock. You understand? Okay. Use a ruler to measure approximately the length as a use a ruler as a lies St. Helena from the most southwesterly to the end of the northeasterly part of the island. Give your answer in centimeters. Here they have just told you do what? Use a ruler and do what? Measure. The distance between the southwesterly and the most northeasterly. You understand? So simply meaning we are measuring between southwest and northeast. Let's come here. Where's the scale here? Oh, sorry. Where's the compass? Yeah, this is the compass. It shows that this is what? North. So northeast is supposed to be here. And this is northeast. And this is southwest. So they are saying most. So simply mean you have to measure from here to the end of this point here. You measure up to there. So having measured the distance there, we get it as you can measure in millimeters, get it perfect. So for me, I measured, I got 148. These are millimeters, but I want it to become centimeters. What do? Need to divide by 10. In that my answer becomes in that my answer becomes 14 comma 14 comma 8 14 comma 14,8. So the answer is supposed to be 14,8 centimeters. The maximum breadth of the island is approximately 10 kilometers. Use the scale of the map given with the answer to question 2.2.6 to determine the estimated area of the entire island. The island is not a rectangular part of it. It's not a rectangular shape whereby we would have said, okay, you're saying estimated. So you're saying the breadth is this much, 10 kilometers, or you have 14,8 centimeters. So also this simply means if you're going to estimate, the area will be L times B. We are estimating at the reason why I'm using this is because this is the only area that is simpler to any person. So simply meaning I will need to change this to kilometers. The same way we used the scale. I think someone remembers how we used the scale here to get the 7,09 kilometers. So simply meaning we shall need to do what? We shall use the same scale to change this. Remember my scale was 37. They give you 5 mile. Then what about if you have 148? Remember it was in millimeters. What is it? Yes, sir? 37 give me, what about this? Okay, we shall do, sorry, it's 42, 37. 42, 42, 42, 42, 42. 42. 42 millimeters, they give me 5 miles. So I need to change the 148 to kilometers. I'm calling them any letter I need. So this is 148 times 5 divided by 42. What answer do we get? But by the way, we shall get that answer. It will be in miles. Afterwards, we change it to kilometers using the same conversion. So I get 17,62. These are miles. I want them to become kilometers. I'll multiply them with 1,60934, which becomes 28, these are kilometers. So this is 28, and this one has a 10. So it will be 10 times 28,3. Which became an estimation of 2 kilometers what? Squared. I'm squaring because I'm looking at the area. So an estimation of 300 kilometers what? Squared. All right. Sorry for disorganization, but please take the concept as it is. Take the concept as it is. Take the concept as it is. All right. We go to the 2.2.8. The population 2.2.8, it says the population density is the number of people found living in each square kilometer of an area. According to the last census is the process of counting the population of people occupying or in a given area. So the last census in 2016, so the last time they counted people, it was 2016, according to this statement. So the last census in 2016, there were 4,534 people living in or living on St. Helena, the island. Use the answer in question 2.2.7 to determine the population density of St. Helena. The learner who is watching this, please take note. From question number 2.2.4, here, don't leave any question unanswered. Why? Your answer is right according to your measurement. Why? You used a different ruler. So from here, you're supposed to get a mark, full marks, 4 marks. Here, reasoning, full marks. We come to this, full marks. You understand? Because they told you measure. Whatever because we are not there to measure with you. You have measured with a ruler and you've given us the answer there. Come to 2.7. Also here, you got your answer. As long as you've tried to get the answer, you've changed it to kilometers and everything, you end up, whatever answer you have here with your values, it will be right. Come to this question, it will be right. Why? The answer from here is based on the previous one. The answer from here is based on the scale that you used up there. You understand? Okay. This will be, use the answer in 2.2.7. So they are saying 2.2, determine the population density. The population density is the number of people found living in each square. So in each square, so that means shall I take the number of people divided by the area occupied. So here we are saying 4,534 divided by the area of this place here. So estimation, okay, we said 300. You might divide by 300 or 283 as I got. Guys, this will depend on what answer you got. When I rounded it up because I was estimating. Estimation, you have to get proper answers. Either here you have 250, but you can't have 250 because your answer that you got on calculator is 283. The answer I got is 283. So I can't say 250. So this one goes to the next number, which is what? 300. So I'll divide by my estimation number. Remember, you are estimating. It's not guessing, but we are closing up. So this one is an estimation of 15,11. But we are looking at determining number of people per square kilometer. So people can't be in commas. So here my answer will be 15 because I'm looking at people. You understand? If you had the opportunity to start a business in St. Helena, what type of business would it be? Now, remember, St. Helena is a port. That's what you have to know. It's a pot. And I told you pots are, I'm not talking of the ones that you use to cook at home. I'm talking of a pot found on a sea. So St. Helena, which kind of businesses will you be doing at St. Helena? Some people might be, okay, they might open up a fishing company. All right. Others might open up accommodation areas, the B&Bs. Why? People come to tour St. Helena, but they can't sleep on their boats, so they need where to sleep. All right. And someone might open up a restaurant for people who are working at the port to eat food. Someone for a port, I doubt whether you can open a school. Workers have learners who need to go to school. Okay, you can open up a school there. You understand? Businesses, that's what we are looking at. 2 marks for any business that you want to open up. All right, let it be rated to ports, all right? Okay, that ends, that marks the end of question number 2 out of 30. All right, let's look at question number 3. When you, I'm here looking at this, what comes in your head? These, we shall call them what? Measurements. These are measurements. And under measurements, we are expecting to look at area. We look at perimeter. We look at volume. We look at surface area. We look at surface area. You see that? We look at surface area. Okay, question number 3. Mrs. Fallacy would like to have a swimming pool at her house. She is comparing the sizes of the 2 shapes of the swimming pool. Pool A, Pool A is rectangular in shape with depth increasing uniformly from 3 feet to 9 feet, whereas Pool B is a cylindrical. It's cylindrical in shape with a diameter of 5 meters. Below are the diagrams of both pools. All right. Take note, it's in metric. When we look at metric, these are measurements, whereas this is in feet, which is what? The imperial. This is that, and okay, we go. Explain the term circumference. When we look at the circumference, we are looking at the total distance around a circular shape. A circular shape. If you move around the center of a football pitch, I mean that place where you move around, that where they put the ball before they start. If you move around, you cover that circle. That's the circumference. If you move around a circular, for example, here, if you move around pool shape B, you start from here, you move around and you come, stop here. That will be circumference. That is circumference. In other words, it's perimeter of a circle. Perimeter of a circle is called circumference. Total distance around a given circle. Convert the length of the rectangular pool to meters. We are looking at the length. The length is in feet. They want it to become meters. What are you going to do? We shall use a conversion factor here. They're telling you 1 foot equals to 0.3048 meters when you have 40. So if 1 foot is 0.3048 meters, what will happen if you have 40 feet? 40 times 0,048. And the answer has to be 40 times 0,048, which is 12,192 meters. All right. They usually say round off your final answers to two decimal places, which will be 12,19. These are meters. Mrs. Farasi claims claims that pool A can hold over 169,000 liters of water. If the volume of the water section A of the pool is 84,951 liters, determine whether Mrs. Pool is correct. Now, this is 8 marks. Please, as a learner, you try to do your best, right? Very well. You will try, or I will ask you to do this, because this is rectangular and the volume is supposed to be. So already they are saying section A of the pool is 8,000. So section A is covered and section A stops there. This is section A. But then what about this section here? What is it? You try to complete this and find out. And it's this section B. Have they given they didn't give the section B volume? Section B volume will be section B volume. It's going to be leave alone this. Sorry. So we shall look at section B. So section B, it will start from here. You understand? So we shall use the volume equals, because it's going to be, if we are looking for the total volume of this swimming pool, so which is going to be section A plus section B. So section B volume will equal to an area of a triangle times the height. So area of the triangle times the height. So already here we have the height of this, but we shall need the full one, which is 6 times the distance from here to there, which is 40. Then times, because we are taking the triangle here, times this other side here, which is 25. All right. So we are proving that section A can hold 169,000 liters of water if the volume of water section A, if pool A, this is you're proving pool A, section A pool is this much, determine whether it's true. So we need to get the volume of section A plus the volume of section B, and it should equal to, if at all it does not equal to this, then it will be invalid. All right. But I've told you that we shall take, because we have volume A already. Volume A is this much, section A, sorry, this much. So we are looking for volume of section B, which will be the triangle part, which is, because the reason why I'm using half base times height, again times another height, because volume equals to base area times what? Times height. That's why you see here in brackets, this one's base area. Anyway, we said we shall take it to be half times the 6 feet, the 20, the 28, the 28, 25, shall I take it to be half times 6, but these are feet. That means we need to first change them. The 6 feet, they need to become meters. So we multiply by 0.3048. I want it to become meter. Then I need to take the 40 feet also, it has to become meter. So I need to multiply by the same number, 0.048. These are meters. That's what I'm looking at. And it has to be 6 times 0.3048. This is 1.8288. Then the 40 will come 12.192. So they have become meters. So I will come and put them here. 1.8288 times 12.192. I'm looking at the area. Times the height, which is supposed to be, we forgot to change the 20. The 25. 25 is 7.62 meters. So we'll come and change this and put there. So I'm looking at the answer now. So this is 84.9505. These are meters what? Cubed. But we want them to become liters. What do? Multiply by 1,000. Why am I multiplying by? Because they've told me 1 millimeters cubed equals to 1,000. So here I have 84,950.54 liters. This is section B. All right. So section B, section A is already here. This is A. This is B. When you add the two, you have 169901, comma. These are liters. So it says it can hold over. Yeah, so the statement has to be true because it's already over. All right, that's how we do it. This one had to, it takes, it's 8 marks. First and foremost, you had to convert. You have to convert. 2, you need to substitute to pick the right formula. When you add, you get the conclusion, it's fine. You know, let's put this mark here. You had to convert. Most cases, the conversion is 1 mark, but it's fine as long as you know the concept. We had to look for volume of section B. But section B, we didn't look at section B only. We looked from here, this triangular part here. This, everything, because when we add the 2, it has to be over 16900 liters. And indeed, when we added them, it's over. So the answer becomes correct. You need to come here and you see the diagram. This is pool B. So the radius, it's needed. Radius is needed, which is diameter divided by 2, which is 5 divided by 2, which is 2,5 meters. So in our formula, we should have 2,5 meters, but it has to be what? Squared. Let's come back here. Yes, here the answer, we've seen it already. It's what? B. Why? We have pi. This is the radius, and we have the height. Pi, radius, and the height. That's what. So B is the right answer. 3.5. Hole B is estimated to hold 65,000 liters of water. Determine the depth of hole B and round off your answer to 2 decimal places. How many marks? 5. Hole B, we've already seen the formula is this one here. And inside here, they want us to determine the depth. Depth will be representing height. A swimming pool doesn't have a height. Why? It goes under. It's off the surface. Swimming pools are built under. They're off the surface. Walls of your room, walls of your school, walls in your house, they go up. They're from the ground and they go up. For them, they have the height. So the swimming pool, it was supposed to be pi r squared times what? D, which is what? Depth. So this is a depth. Anyway, in 3.5, they want us to determine the depth. So D is representing what? The height. Anyway, what you're going to do for me, let me see if I have space yet. Okay, it's fine here. What you're going to do for me is pool B. Pool B, everyone has seen it. It's a cylindrical. Pool B, it's a cylinder. It's a cylinder. So if volume of is the same as pi r squared D, how do you get the volume of D? This will be V divided by pi r what? Squared, because you're making D the subject. Okay, you come back here and you say, So volume is this much, but this much has to be changed to meters cubed. Why? The depth we are looking for, the answer has to be in meters. You understand? So if you're to change this to meters, you need to divide this by 1,000. So the volume is 65 meters what? Cubed. So this is done. The radius, we already saw it. Radius is 2,5 meters. It's fine. Understand? 2,5 meters squared is okay. But then what about the depth? Okay, the depth will equal to volume divided by pi r squared. So our volume, we've seen it already, like 65 divided by pi is 3,142 times 5 squared. So when you do that, 65 divided by 3,142 times 2,5 squared. So the depth is 129,30 meters. Let us repeat it here. They've told you the volume of the cylinder is 63,000. These are liters. But they told you already that if you only have 1 millimeter cube, you have 1,000 liters. So we need to change this to meters cubed. So we divide it by 1,000. In other words, this is what? 63 meters. Sorry, 65, 63. Oh, sorry, 65, not 63. Change this to 65. This is 65 meters what? Cubed. So if this is it, but remember the volume, how did they get it? They took pi r squared what? H. We saw that our r is 2,5. So we come here and say 3,142 times 2,5 squared times the depth, which is missing, should give us the answer as what? 65. So you divide through by you divide through by 3,142 times pi r squared. So when you do this, the answer here, the D will become 129,29,6, as in 296, which is approximately 29 that, which is approximately 129 is meters. Okay, 30.6. Hole B is filled with water at the rate of 1,5 millimeters cubed per minute. Hence, Mr. Bahaza claims that it can be filled to 92% if its capacity by 8 if it's 92% of its capacity by 8. So, and if the feeding process starts at 7:30, verify whether so by 7:30 the pool is at 92% full. So you need to look for 92% of its capacity. Remember, the capacity of pool B is 65 meters what? Cube. So by 730, it's 19. So we need to know at what level is it. So you will take 92% times what? 65. So it's already at 59, 59,8 millimeters what? Cubed. I'm using millimeters cubed because also the rate is what? 1,5 millimeters cubed. So we shall ask ourselves, this rate is per minute. So how many minutes are remaining to make it to 8? So the minutes remaining are 30 minutes. So in 30 minutes, how many meters cubed shall we require? 30 minutes, which is actually you'll get this per minute. So times, okay, we shall get that in 30 minutes. It will be 1,5 times what? 30. So we need 45 meters what? Cubed in 30 minutes. So how many millimeters are remaining to fill it up? Because it takes up 65. So we shall say 65 minus 59,8. So we are remaining with 55,2 meters cubed. So 30 minutes will be too long. We shall say it's what? Invalid. It's invalid. Because that's too long. It's invalid. It's too long. 37,7. Sorry, 30.7. Mrs. Bahati chooses pool A. Give one possible reason why she opted for pool A, even though pool A uses more water. Pool A, it has for both professional and amateurs because it has a deep side and a shallow side. Whereas pool B, it's flat, doesn't have any. All right. You can think of it. And yeah, pool pool A has sections of which I'm not that much sure. Or you can say the design or the shape of the swimming pool could have influenced her to choose pool A. You know, please do not leave. Please do not leave questions like this unanswered. Give your reason. All right? Give a reason. It will be right because this is according to you. All right. When Mrs. Bahat wanted to swim, the new pool, the temperature of the water was 19 degrees Celsius, and she said would be only swimming if the temperature of water was 25 degrees Celsius. The temperature must increase by 6%. Sorry, 6 degrees Celsius. Calculate what the temperature change could be in Fahrenheit. So temperature change is what? 6. It's supposed to be changed in Fahrenheit. So we shall say, now the reason why it's 5 marks, look at the formula given to you. Look at the formula. Yes, the formula given to you, look at the formula. The formula says f minus 32 into brackets divided by 1,8 should give me. So you already don't know the f, but divided by 1,8 equals 2, 6. Because this is a division, we need to multiply the side. So we shall say f minus 32 will equal to 6 times 1,8. You see, this is a number. It will also jump over here. It becomes what? Plus. So your f becomes 6 times 1,8 plus 32. So the degrees are supposed to be this much in Fahrenheit. And they say calculate whether the temperature in Fahrenheit, calculate what, yeah, this is it. Question number 4. Sakili has enrolled at University of Johannesburg and is renting a bachelor flat in Johannesburg. Use the floor plan below. Use the floor plan of Sakili's flat below and answer the questions that follow. All right. The floor plan, some people, sometimes we might be asked what's a floor plan. You might say a layout of how a room will be in the future, or how the flat will be, sorry, the house will be designed. It will be organized. It's a layout, a drawing showing how the building will be. You ask what's a floor plan. All right. Question number 4.1.4. Write down the number of doors which open into the living area and the kitchen. They open into. So here we shall say we have one. It's opened into the living area. We have two. That's opened into the living area. And we have three that has opened into. We need those that go inside this space here. So here the answer becomes 3. There are 3 doors. Use the given scale to calculate the actual length of the bedroom, including the mechanical room. So remember they're saying you use the given scale. This simply means you need to first measure because you don't have the measurements. So they want you to measure from this point here and you go up to this point, including. So this is what you're measuring. See that? You can measure that. Then the answer you've got now, for me, I've got 86 millimeters. You understand? So I'm going to use that to get the actual length. So I will come down here. The scale that we've seen, the scale is here. The scale says if you only have 1 unit on paper, you have 100 units. So if I have 86 millimeters, how many units will I have? I need to multiply by 100. So I end up having 8,600 millimeters. But because they want it in actual, so the actual measurement that we can have, it's either meters or kilometers. So we change this to meters because definitely you cannot have a room that is in kilometers. I have 8,6 meters. 8,6 meters. 5 marks, how were they given? You measured, you multiply by 100. You came, you divide, I got the answer, you divided by 1,000. The final answer, you have it there. 4.4.4.1. Right, convert the area of the bachelor flat to meters squared. Here we go. We have the area given to us, but it's in feet squared. So feet squared, they want it to be changed to meters squared. The conversion factor they have given you, it's centimeters squared. You see that? So let's go and we shall say, I'll pick the conversion factor first. This is question 4.1.3. It says, if I have 100 centimeters squared, I have 0.107639 square feet. Indeed, this time around, I have square feet that I need to change to meters. So I will need to bring the square feet. I'm going to change. I'll put them on the side of the feet. If 100 gives me this much, what will give me 322,36 feet squared? Remember, the answer here is that you will get, let's call it h. The answer that we shall get here to be in centimeters what? Squared. So let's cross multiply. 100 multiplies this. So you get 100 times 32, times 322,36 divided by 0.17. All right. So the answer there, we shall get it as the answer, you have it as 29,000. Sorry, it's 299,482,53. These are centimeters squared. Now, from centimeters to meters squared, what do we do? Centimeters to centimeters, we divide by 100. Centimeters to come to meters, we divide by 100. But now we are looking at centimeters squared to meters squared. We divide by 100 squared. So we shall divide the answer that we've got by 100 squared. 100 squared, and the answer becomes 29.95 meters squared. That is the answer. All right, we look at 4.1.4. 4.1.4. This is a question, and it says, Takeda states that he likes an open plan flat. Does this bachelor flat qualify as an open plan flat? Give a reason for your answer. An open plan flat. It's a kind of flat whereby there are no walls. What do I mean by walls? There are no walls that separate the living room from the kitchen. Whoever is in the kitchen can see whatever is happening in the living room, and whoever is in the living room, you can see what's happening in the kitchen. Definitely, you might have, yes, it's called the walls on the bedroom, yes, because it's a private part of it, and the bathroom, definitely, that's a private place also. So this one qualifies to be an open plan because there are no walls. They are saying, does this bachelor, you start by saying yes. Why? It has no walls between the kitchen and the living room. That's why it's an open plan. All right. Okay, 4.2. 4.2 tells us Mr. Botha, the owner of the flat where Sakele stays, wants to build a fire pit in the backyard. He searched on the internet and got the idea as indicated in Annexure B. We shall see it soon. Use Annexure B to answer the following questions. The hole for the fire pit must be 4 feet wide and 12 inches deep. It's a pit. That's what you're looking at, deep. Why? It goes down. All right. So these are the measurements. These are conversion factors. 1 foot equals to that much, 1 inch equals to this much, and 1 gallon equals to that much. Okay. Determine the radius of the fire pit. Even before you look at the diagram, everyone knows that radius, what comes in your head? I will need to divide the diameter by 2. And they have said radius in centimeters. Having divided it by 2, I need to change it to centimeters. Okay, let's look at the next one. All right, this is the next year. This is the next year. This is the next year. So this is from here to there. This qualifies to be the what? The diameter. Together. How deep? The depth is there, 12 inch. They're showing that it goes down. All right, let's go back to the question here. Even though you didn't look at anyway, it's fine. Even though you didn't look at the diagram, you would tell from here that 4 feet wide. It's a pit. And how would you know that it's a cylindrical fire pit? No, you would not tell until they ask you the radius. Anyway, so we are going to change the 4 feet. We divide by 2. So we get our 2 feet. These are supposed to become centimeters. When you come here, they have told you 1 foot equals to 30,48 centimeters. What about if you have 2? So we shall need to multiply this by 30,42. The answer becomes 60,96. Don't forget the units. These are centimeters. So our radius is 60 in centimeters. Our radius is that much. Okay. Determine the volume of the fire pit in centimeters cubed. So volume of the fire pit, we've already seen it. It's cylindrical in shape. Oh, and they have given the formula already here. So we are going to substitute into this formula. Pi, it's this number here, sorted. Radius, we've just seen it now, sorted. The height. The height is going to be represented by depth. But remember, the depth is in inches. So it also has to change to centimeters. Why? The final answer is needed in centimeters cubed. So what we're going to do, let's first do this. Radius, we've already seen it as 60,96. These are centimeters. The height is going to be 12 inches times 2,54. What am I doing? I'm changing the 12 inches to 12 inches to what? 12 inches to centimeters. I end up having 30,48. These are centimeters now. So I will go ahead and substitute into the formula. So now the formula says volume equals to pi r squared h. Our h is represented now. It will become d, which is the depth, which is substitute 3,142 times 6,96. Don't forget squared times 30,48. So the volume becomes, the volume is 383,073 centimeters cubed. That's how we get the answer there. This is question number 4.2.2. 4.2.3. What is the formula used to calculate the boundary around the circle? Now, in your head, you have to ask yourself, what's the boundary around the circle? In other words, you're looking for what we call the circumference. If not the circumference, it's the perimeter. Circumference. If it's not the circumference, we say this one, the perimeter. Now, for the circle, it's a circumference. If it was a triangle, rectangle, square, it would be perimeter. So now they're asking you which one will be right. Now, remember very well that circumference will always equal to 2 pi r, or you can use pi by d. The circumference of a circle equals to pi d. This is okay. A is fine. Circumference, no. 2 is missing here. No. This is area. Volume, yes, but you can. Okay. Formula to look for. So here the answer is supposed to be A. Hence, calculate the circumference of the hole for the fire pit. Now, this is simple. Oh, they said to 3 decimal places. Now, take note. Whoever has used centimeters, you'll get your mark. Whoever has used feet, you'll get your mark as long as you're. So now, circumference, we are going to use the one which says pi d, since we already have the diameter there. So it becomes pi 3,142 times the diameter there. We saw it as 4 feet. So 3,142 times 4. Don't forget the units. The person there will have 12,568. These are feet. If you didn't want it in feet, you would say 3,142 times. Now, the 4 feet has to change to centimeters. Because for those ones who don't want, you see, 1 foot equals to this much. So what about if they are 4? We shall multiply it by 4 times 30, 48. Together. So 4 times 30, 48. Which becomes, so you come here, you say 3,142 times 121,92. Which is 383,07. These are centimeters. A layer of 35-gallon buckets of lava rock must be placed in the hole. Mr. Botha said the 2 and 3/4 of 20-liter bucket is equal to 5 bucket. Verify his statement and state whether there will be surplus or shortage. So all right. When we interpret this, they are saying 5 gallons. It's the same as saying 5-liter buckets. But now these are 5-gallon buckets of lava rock must be placed into the hole. Suppose I said that 2/3, 2 and 3/4, not 2/3, 2 and 3/4 of a 20-liter bucket is equal to the. So we say the 3 In other words, this is 15 what? These are 15 gallons. Are equivalent. That's what he says. Are equivalent to 2.75 of a 20 liter. So now take note. These are liters. These are gallons. So they have to have the same what? Measurement. So we shall look for the gallons, change them to liters. So these are 15 gallons, change them to liters. We shall use a conversion on top here, which says 1 gallon equals to 3,7854 liters. So if we have 15 gallons, that means we shall have to multiply by that number there, 3,7854. We want it to become liters, so 15 times 3,7854 equals to 56,81. These are liters. Put it aside. Then this other side, you don't need to look for liters, but otherwise, we need to look for 2.75 of 20 liters. So what is it? That's what we are going to do. 2.75. This is same as 11 out of 8. Ne? Sorry, 11 out of 4 times 20. So 11 out of 4 times 20, we end up having 55. 2.75 20. So 56,78, it's not the same as this. So it's what? Shall say it's valid. It's invalid. Question number 5. Study the percentile chart in annexure C. Percentile chart, when you look at it, in most cases it will be BMI. Actually, it's BMI. And we shall be looking at BMI. So they are saying study the percentile chart C and answer the questions that follow. Coach Maxwell, the trainer at a local athletics club, uses percentile charts to determine the health status of athletes who are joining the club in order to determine the best exercise for them. Coach Maxwell allows athletes whose BMIs are between the 5th and the 85th percentile to join the club. What does the abbreviation BMI stand for? BMI, B stands for body. Then the M stands for mass. And the I stands for index, body mass index. That's what it represents. What do we use it for? To tell the health status. It's used to tell or to determine the health status. It's used in babies and sports people. Actually, for human beings, this is used in hospitals. Hence, determine the maximum BMI that a boy should have to be able to join this. So to join the club. Determine the maximum. So the maximum BMI a boy should have, it's between, you remember they said between, the lowest has to be on the 5th percentile and the highest has to be on the 85th percentile. Let's go to the next year. So the maximum here So this will be the maximum BMI, but it's in between 26 and 28. So this line here, it's going to be the 27. So we shall say it's 27 kilograms per meter squared. Twenty-seven kilograms per meter squared. Hence, determine the maximum weight of a boy who is 1,8. Take note of that. 1,8. This will be the height, and whose BMI is considered healthy. You see that? So we're going to determine the weight, the maximum weight. So now the BMI is considered healthy. Let's go to the chart and we see. Do we have any conclusions here? Let's see. They've not told us of any the percentage of employees for a healthy person. Anyway, they said maximum is supposed to, so if it's 27, what is the math? Okay, we shall work backwards. So they have told us the BMI equals to weight in kilograms over height. What? So we are looking for the weight now. What's going to happen? It will be the BMI times the height. Will give us the weight in kilogram. The BMI, you can also use it as this. Let me see. You know that triangle for speed. So BMI equals to weight over height squared. So if you're looking for weight, the BMI will multiply with the height squared. If you're looking for the height, definitely we remain with the weight divided by the BMI. But here we shall find the square root. If you're looking for the BMI itself, we have weight over the height squared. You can use the triangle like this. You can use the triangle like this to determine the BMI. Okay, so here we go. We have the BMI already as 27 times the height that they have given us, 1,8, but now you're going to square it because the height has to be squared. You don't square the meter only, square the value for the height. Everything is going to be squared. So you get the answer as 27 times 1,8 squared. You have your weight as 87,48 kilograms. 87,48 kilograms. Put together? Yeah. 5.1.4. A 14-year-old boy who weighs 48 kg, 48 kilograms, and whose height is 1,3 meters, claims that he qualifies to be admitted to the club. Calculate the BMI for the boy. So easy. As we did, we say BMI will equal to the weight over the height squared. The weight has to be in kg. The height is in meters, nothing to convert. All we shall do, we shall take 48 kg divided by 1,3 squared. Let's do that. So here the answer becomes 28,40 kgs per meter squared. So does it qualify? We need to go and confirm. We need to go and confirm from the annexure there. Where is 28? 28 is above here. This is the BMI for this boy. You see that? The BMI of a 14-year-old. What are we going to do? We'll draw a straight line here. And when does it, that straight line, you come here, 20, because you go to the 28 comma something, you come and check, you see where it takes it. It's already too far. So it's in between the 9th, 5th, and so the boy does not qualify. Does not qualify. Why? The coach wants between 5th percentile and 85th percentile. For him is above this already. So he does not qualify. It's above the 85th percentile. Anyway, question number 5.2.1. Use annexure D. We check on annexure D. Wow, this is a map, and the name of the map is called a strip map or a street chart. All right, straightforward. Shows from one end to another. All right, determine the distance from question number 1. They're telling us determine the distance from Colesberg to Beaufort West. The distance from Colesberg to Beaufort West. So let's go to the next chart. We shall look for if this is Beaufort West. Sorry, Colesberg. It's at 778. All right. Then we go to Beaufort West. It's here. Beaufort West at 460. Now, if you're using the right-hand side, for example, this, so we shall need to subtract the bigger number minus the smaller number to get the distance. Same applies as its other side. We shall take, because the reason why I'm taking this is because Beaufort West is on this line. So still here we shall take it to be 544 minus 266. If you have to use the left-hand side. So 778 minus 460. We have the distance as 318. 318. And this other side, also this other side is what? 310. When you look at the strip map, it's straightforward from one end to another. On the left, okay, this map is from Bloemfontein to Cape Town. So from Bloem, on the left it shows from Bloem, Cape Town, whereas on the right shows from Cape Town to Bloemfontein. You still see the distance is the same. 999 kilometers. Also here 999. So the numbers that you see in between here, this means the distance from the main road up to here, it's 18 kilometers. The distance from here to this place is 24. These small numbers that now, these are the routes that you're using. You understand? The distance from here up to there, this is N12. You'll be having 181. Okay, so the distance between Colesberg and we are saying it's 318. Don't forget, these are kilometers. Determine the probability of driving through or pass a town starting with letter T along N1 from Cape Town to Bloem. A town that starts with letter T. Let's go there and we see. So I'm from Cape Town. This is Pal. No. Was it? No. Is it? No. Three sister. It's one. Right. So it's only one town that you pass that starts with the letter T. So after, how many towns are we counting? We are counting 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 1. A town that starts with the letter T. Oh, whoa. We also have this one here. Sorry, there are 2. We have 3 sisters and we have the Tulsi River out of 9. So the answer here becomes there are 2 towns out of the 9. So this is the answer, probability. Two point three. 2.2.3. On his way from Cape Town to Bloemfontein, Coach Maxwell stopped at Johannesburg for 45 minutes to have lunch. His next stop was Beaufort West 2 for 15 minutes. And then later he stopped for 15 minutes. So the trip from Cape Town to Bloemfontein took 9 hours, 15 minutes in total. Calculate the average speed, the nearest kilometer per hour, at which Coach Maxwell traveled from Cape Town to Bloemfontein. Justify your answer by calculating whether he kept the maximum speed limit of 120 kilometers. So number 1, what you're going to look for, what is the distance? But the distance, we've already seen it as 999 kilometers. That's already seen. What I want us to look at, it's the time. How much time did he spend? So now, if he took 9 hours, 15 minutes, 9 hours, 15 minutes to cover the whole trip. Of 9 hours, 15 minutes, we have to subtract the 45 minutes he was not traveling. The other 30 minutes, the 15 and the 15, he was not traveling also. We need to subtract this. Approximately, this is 1 hour and 15 minutes. It has to go off from here. So when you subtract 9 hours, 15 minutes minus 1 hour, 15 minutes. What do we end up having? So we shall end up having 8 hours. So he drove using 8 hours. So the speed will equal to distance over time taken, which is 999 divided by 8. 999 divided by 8. So we have the answer as 124.88 kilometers per hour. Indeed, he was overspeeding. He was overspeeding. Why? He went above the 120 kilometers per 120 kilometers per hour. Okay, we look at question number 5.2.4. The fuel consumption for Coach Maxwell's car is 5.9 liters for every 100 kilometers. And the fuel, the capacity is the fuel capacity is 45 liters. All right. So here they're saying verify whether it was necessary for Coach Maxwell to refill at any of the stops made on this way. So how are you going to find out this? You're going to see that he was traveling from Cape Town to Bloemfontein, whereby it's going to cover a distance of 199 kilometers. You understand? So you ask yourself, for this much kilometers, how much fuel do we need? So we shall come and say, if 5.9 covers only 100, what about how much fuel will I need? or 999. 999. So this will become 999.9 divided by 100. So it needs a coverage of 58.94 liters. So if he took a full tank, it would not be enough for the full journey. So he had to another part that you would also consider, it's verify whether it was necessary for coach to refill at any stop he made on his way to Bloom. Show all calculations. Remember, coach had to travel in his way from Cape Town to Bloemfontein. Yeah. So here also they're asking you, it's still, you consider using one way, or other people are considering two way. Even though it's two way, that means he has to cover 908 twice, which will become 999 times 2, 1980. These are the kilometers covered. In these kilometers, we need to know how much fuel do we need. We shall say this much. We divide by 100. We multiply by the 58. Sorry, 5 comma. So he will need 182 liters of fuel. Indeed, he has to refill. Even single, this was a single trip, just going. This is a return trip. It's the same story. He has to refill. One full tank is not enough the whole journey. Thank you very much.